Caleb likes to make things up sometimes. Okay. So let's just start going. This is just like these problems all are kind of the same theme, except one stuck in there that's not. I don't know how. Whatever. We'll go through it anyways. Yeah, so let's just start going. I'll start doing stuff and give you one similar, then I'll do another one, give you one similar, and try to figure it all out. So, if I read through this first one, they are giving me, so the units are really important because that tells you what level you're on. So if they're giving me W of T, and that's degrees, is that the original, the derivative, or the second derivative? That's the original. If it was the derivative, it would be like degrees per minute. If it was the second derivative, it'd be degrees per minute squared, or minute per minute, because that's like acceleration, you know. So this is the original. And then they're saying use this to estimate W prime of 12. Well, what does prime tell you? Derivative or slope. I want to know the slope at 12. Well, all I have is these 5 points, and I don't even know what happens in between there. So you can't assume it's like a constant growth or anything, but the best way I could estimate 12 would be to go, okay, 12 is in the middle of 9 and 15. So I'm going to find the slope between those 2 points. So 67.9 minus 61.8 over 15 minus 9. So that's like 6.1 over 6. And what would the label be? So it'd be degrees per minute. Because now we're at a velocity level. So you have to have like a per second or per minute or something. And then interpret the meaning. So what is that telling us? Derivative tells us like slope or rate of change, right? So what that tells us is the temperature has this rate of change. So is the temperature increasing or decreasing? Increasing by that amount. So interpret the meaning would be temperature increasing by 6.1 over 6 degrees per minute. Is that one okay? Well, that's a few of these are like this. I think if you just saw it the first time, it might be confusing. You're like, what am I supposed to do? But then once I show you one, you're like, okay, this is easy. Now I can do the rest of it. I hope that's the case. Second one. Try to evaluate the integral from 0 to 20 of W prime. Well, that is the fundamental theorem of calculus. The integral from 0 to 20 of W prime, wouldn't that be WT between 0 and 20? Wouldn't that be W of 20 minus W of 0? Does that make sense? Stop telling me to wait. I'm waiting. Everybody's yelling at me. Yep. That's the fundamental theorem of calculus, right? The integral from a to b of like f prime of x is going to be equal f of b minus f of a. So we usually put that step in the middle. It's like, okay, f of x from a to b. But that's exactly what we're doing in this problem. It's just going through the fundamental theorem of calculus. We're going to plug in w of 20 minus w of 0, so that's 71 minus 55. So that's 66. That's 16. You know what to subtract. What's the label on that? Just straight up degrees. So I went back up to the degrees level, right? Because I integrated. So this would be just degrees.
It says Fahrenheit, so should it be degrees Fahrenheit?
Sure.
When you write degrees Fahrenheit, does the little bubble go before the F or after the F?
A little what?
A little bubble for the degrees.
I think it's before, isn't it?
It's usually the number of the bubble, then the
Yeah, it'd be like 77 degrees Fahrenheit.
Yeah.
Fahrenheit degrees.
Yeah, I wouldn't go 77 Fahrenheit degrees.
I'm just saying the wrong thing.
No, I wasn't saying that to like make fun of you. I was double checking myself. Okay, anyway. They also ask you to interpret the meaning of that in the context of the problem. So, at the beginning of this situation, the water was 55 degrees, and 20 minutes later it was 71 degrees. So that's all it's saying. Is in the course of that 20 minutes, the water got 16 degrees warmer. Is that okay? Yeah.
I just said the amount the temperature rose during the 20 minutes.
Yeah, that's fine. So again, my wording isn't the best. I don't think I'm very anything special wording at all. So anything that you're saying along those lines, if we're saying the temperature started here and rose 16 degrees during those 20 minutes. Part C, they want us to do a left-hand Riemann sum approximation. That's really common in these two. You'll have to do either LRAM or MRAM or RRAM. So if I'm doing LRAM, remember it's like base times height times base times height, or base times height plus base times height plus base times height. You're just adding up rectangles, you know? So this first rectangle, the base would be 4. And what's my height if I'm doing left-hand sums? 55. Plus 5 times 57.1 plus 6. You guys see where I'm getting the numbers from?
Yeah.
Plus 5 times 67.9. Then don't forget to multiply that all by 1 over 20. Because it tells you to multiply it by 1 over 20. Yeah. And that comes out to 60.79.
What's the point of that? Just because they feel like it, or?
Well, what's the point of that? What is that doing? That's a formula. That's the average value. So like the average temperature in those 20 minutes was 60.79. I don't even think they asked you for that.
Yeah, they ask you for the reason. What it means.
They ask for that?
No, they're not asking you to interpret it. They're saying is it an overestimate or an underestimate? And then explain why it's one of those.
That was an
So what are we looking at to see if it's an over or under?
If it's increasing.
Yeah, so this is getting bigger, right? These values all go bigger and bigger. So if I'm going up and I'm taking the left-hand point in each interval, am I overestimating or underestimating? I'm underestimating. So you're just going to say underestimating since W of t is what? Increasing. Don't say since it is increasing. That doesn't do anything.
I see the temperature steadily increasing.
You can say the temperature is increasing. We don't know if it's steadily increasing because we only know those 5 points. So it could be like zigzagging in between, and we don't know. I think you'd probably stick points for that. But okay, part D. So notice this is on the calculator section. So I'm gonna have you guys type this in just to kind of review the calculator stuff. But what they're saying is, okay, for the first 20 minutes, here were your temperatures. By the time we got to the 20-minute mark, we were at 71 degrees. For the next 5 minutes, it's this W prime of t is this equation they give me. So if I want to know the temperature, that's the rate of change of the temperature. If I want to know the temperature increase or decrease during those 5 minutes, what do I do with this equation? I'm going to integrate it. So I'm going to go 71 plus, because the temperature is 71 at the 20th minute, right? And then from 20 to 25, I'm going to integrate W prime of t. And you can write W prime there, or you can write down the equation if you want. But at this point, you're just typing it in your calculator. So please everybody do that and make sure that you get what you're supposed to get. Kyle. Because at the 20th minute, we weren't starting at like 0 degrees. It was already 71 degrees at the 20th minute. And Wilmer, I just noticed it does say the function is strictly increasing.
I mean, I didn't see it, so
Well,
that's still not bad.
in the answer, they say because it's strictly increasing.
Yeah.
You get it in the first
Online it says it's strictly.
Oh, it does. Yeah, the very first sentence. T is modeled by a strictly increasing function. Yeah, okay, so it is increasing. So here we go, Julie. I'm sorry. Here's the answer. You want the answer?
Yeah, I would answer.
I have to try every time.
My bad.
So if you're not getting what you should be getting, let me know so I can come look at your calculator or whatever. It's on the board. It's on the answers I just gave you.
Oh, it's.
What is this? Oh, okay.
Well,
Nah, yeah, you know, probably 20.
Oh, I forgot that stuff. Did you choose more also?
what attendant would you rate experience? Education, everything.
It was 23. Any calculator issues? Yes.
How do you want to choose? Okay, well, she was last night. I was like, what? But now it's like, okay. Last night I was like, what is this? I hated any of it. I started the first one by doing I'm just like, yeah, I'm just gonna. I'm just not gonna know. It's just now. No. Like that. Now it's just probably like I've always known now it's probably. But it makes sense. You're helping with the problem. Saying, hey guys, we're gonna help. Well, that wasn't open to everyone. You just showed up.
Did I give you? You gave me batteries, right?
Yeah. So you're offering 5 people.
Caleb, the answer is on the board and in front of you in a packet.
I had like one thing. I didn't realize. What's the original?
I forgot I borrowed those. Thank you.
Yeah.
All right, we good?
Yes, we are.
Yeah.
What?
We're Gucci.
Well, why'd you have your hand up if we're
I was
good?
gonna ask you probably something else.
But now you don't want to anymore?
I wanted to start class.
Gotcha.
You're sorry,
Let's go to number, 2011.
wow, there's
Very similar. A pot of tea cools. This problem here, I want you to try that. You do right now. Maybe you don't. I don't know. Maybe because
I still love it.
you have to specify degrees Celsius, degrees Fahrenheit.
you should specify degrees.
Well, you put a little circle, it's fine.
So here's the thing. If you're ever in doubt, just put it. You know, it's not going to hurt.
Yeah, it's like put a C or not right after your thing.
This is a calculator question, yes. You are allowed to use a calculator on this question. You don't really need one until part D, but you can. If you're watching the video right now, you're probably going to want to fast forward about 5 or 10 minutes. I was talking to you guys.
Let me say hi to her.
Jeez.
Wait, can I say hi to her? Well, probably not now because he just told
But
me.
she's
Hey,
fast
let's
Oh yeah, I
try-
just said fast forward. So.
Yeah, so she's probably not
Yeah,
gonna talk bad about
Yeah, let's talk bad about her.
She's just fast forwarding anyway.
Yeah.
So.
Yeah.
Just kidding, Alexis.
But now if she didn't fast forward, she's going to be carefully listening to the next 10 minutes.
Is the trapezoid? That's not the average, right?
Trapezoid is you find LRAM and RRAM and you average them together.
That's the average one?
Yep.
What's the trapezoid?
Trapezoid is you find L, the left hands,
That's how much.
and the right hand, you average them together. Was that like a joke? Was that...
Does anybody really know?
Yes, Kyle.
He wants us to find the integral of just degrees Celsius. But what would that be? Because it doesn't say H prime T, right?
Where?
In V.
Well, when you multiply by 1/10, divided by the length. If I had $1 for every time in this class I've told you guys what integral divided by length tells you, I could have retired. Tells you the average value.
Right.
Yeah, I just don't know how to apply that to the problem.
Yeah, but how do you find the integral?
Find the integral of that though.
You use a trapezoidal sum with 4 subintervals.
Yeah. I meant like they say you explain it in the context of the problem. I haven't thought a lot about it, so ignore it.
I can see what you're saying.
I have a question.
For a second.
Even you.
Yeah, I know.
Even you. Do you know where your grade is compared to other most of the schools?
Probably not that great. This constant.
Even you. No, not this much.
That did seem slightly arrogant.
So if you say that like something is decreasing at a rate of negative, is that
So that would be increasing.
that would be increasing?
Yeah.
Okay, so we have to like
So, yeah. I understand the question. I just don't know what else to do to get average value formula to stick in your brains. I think I might be able to help you with the y. So you're saying like when we go, there's nowhere to go up above that. Yeah. So let me see if this helps you. So if we start at, let's say acceleration, that would be, let's just say meters per second squared, right? So then what's velocity, Kyle? And then what's position? Okay, so when I integrate meters, so as you go up, you're basically multiplying by a seconds. So like if I multiply this by seconds, it cancels, there's only one left. Multiply this by seconds, it cancels, there's none left. So when I integrate this meters one, the level above that would be times this. You with me? Yeah. But then when you divide by 10, you're dividing by seconds. So now you're still at the meters level. Does that help?
Good explanation.
Thank you. Thank you. I was pretty proud of that one too.
Now you're regretting telling Alexis to press forward.
Yeah, Alexis rewinds. That was some pretty cool stuff because nobody talked about you at all.
Is she the new Steven?
Yeah, how's Steven doing? I don't even know.
I wonder how is Steven?
He asked a question like a week ago or something. Not sure that YouTube was the best resource for that. He said he thought he was right. I think I'm confused. I never really thought of that before he was Yeah, so it integrated after the last year.
Oh,
After
shit.
the executive had time to do like how you roll.
So,
Lots of over there.
Mr. Davis, I think I might have done this wrong. When you do the trapezoid thing with Boogie Boogie, do you don't use, I think you did midpoint.
That's different.
How do you do trapezoid?
You do the left hand, then you do the right hand, then the arms together. So just think about like drawing that out. If I do the left hand sum, if this is my the left hand sum, it's going to be this rectangle. If I do the right hand sum, it's going to be this rectangle. If I average those,
Nice.
I mean, a triangle I found.
which is a triangle. That makes sense.
Yeah. So it's.
So you get it in one. It's kind of big.
Oh.
It's pretty deep.
Wow.
What do you say? Wow, there's nothing.
No, I'm not even looking at that.
You're like in your brain saying wow.
Yeah.
Are you
I
still?
don't like integrals.
Are you still deflating Baymax?
A little bit. I am at a point where I can keep my head up and I can do mundane tasks as long as I'm sitting. So I think that's enough to get me through the other 7 hours.
So I have to like write the full string of things out.
Yep. Dangerous idea.
Yeah.
Porter's got like every joint of his body is broken. Search everywhere.
I don't know, but I think Porter would fight dirty.
I think Porter would be the person who would be gone for a night.
I think Mahaney might have an edge because of the nails. Also, she wears heels like Lucian does.
Yeah, like one hand heel. She could stab someone.
Yeah, but like even flats are still kind of weird.
This is right. Is there an easy way to write that? Okay. Or is that actually what I have to write out?
I mean, so you could if you look at the answers. They wrote it out like it's less writing, but potentially more confusing. Right? So look at that and see like that's not very nice.
Oh.
See what they're doing. So that works too. If you want.
So wait, what's the difference between that and midpoint?
So you're
Because I just did like.
midpoint because you don't know the value at like t equals 1.
Oh no, I was taking just like between 0 and 2. I was saying 63.
So you're assuming that it's a constant growth, but it might wiggle around in between there. We don't know.
But isn't that what they're doing here? Because they're taking 66 plus 65 by 2 plus 63.
They're going. Yes. So there, but it's, what that is the left. That's the trapezoid method. Midpoint method, you actually need to know the value of the midpoint. So the trapezoid method assumes that it's linear.
Okay. But if I had just put on the AP test 2 times 63 plus 2 times what is it?
26.
Yeah.
Plus 3 times 56.
Yeah.
Plus 4 times 48.
Yeah,
Plus 1.
that's originally what I wrote out.
Yeah, that works.
I did all that. And then
But
I
that
erased
led
all
us to
this
this very productive conversation. Look how much you got and how much you learned. Wasn't it worth it?
What a birthday gift.
Happy birthday.
I wrote all this out.
It's like 10 numbers. You act like you wrote a 7-page essay.
It is 1, 2, 3, 4, 5,
I
6,
don't
7,
care
8,
how many
9, 10,
numbers it is.
22 numbers.
Same.
Someone was extra. You have to write stuff anyway. So my 10 estimates are pretty solid. And the 10 numbers is what is causing you to whine like 3 hours.
I'm just glad I have a bad reason I can read the answers that I have before.
Shoot. Is this the thing that's scripted files like super hard for me to know?
He asks, okay, so if I integrate, you know, if you integrate the city with position, use like local data position. So the thing is with this one though, is not, you're integrating position, so here's what I show. You start on use percent square, you integrate that. Technically, in theory, you can have plus. You're like, you're adding up plus. You're multiplying by half. So then this is what you're adding. But in this question, you're asked to do by that value, which means you're dividing by seconds. We're still at the
Degrees.
So, by the average value, I guess you go up a level and then divide it by times, and then pass the level.
Got it.
I never really know why.
Yeah. I just want to like assume because like what you're doing is like you just figure out how much the temperature is changing, so it just kind of
Just stay on the level. How's this one going?
Hey, I see your car. That was broken. So where's the setting?
It's a little bit. It's not.
Exactly.
That was white. Mine's like kind of white.
Maybe it's just the light outside.
Are there questions I can go over on this problem? D? Biscuits kind of came out of nowhere. So, this is B prime. So that's not telling me the temperature of the biscuits. It's telling me the rate at which the temperature changes, right? So it's a derivative. So if I want to know the temperature of the biscuits, well, part D, they started at 100 degrees. So at the very start of this problem, the biscuits were 100 degrees. And then I want to know how much they cooled in the 10 minutes. So what do I do with that derivative or that rate to find out the amount that they cooled? You integrate it. So I'm going to integrate from 0 to 10, and I can just write B prime, or I can write the actual equation, whatever. And then you set that in your calculator, and that gives you 34.183. Question says, at time equals 10, how much cooler are the biscuits than the tea? Well, what's the temperature of the tea at 10 minutes? 43. So you just go 43 minus 34.183 would be 8.817 degrees cooler. Does that help? Is that right? Yes, Nate.
Just for
That is
clarification.
quite a hand raise.
Sorry.
That was impressed.
Anyways, so just for my personal clarification and anyone else, so your BT, you would replace it with the equation that's given and then plug in your 0 to 10 D's.
I understand what you're saying.
Start over.
Okay, so the BT that's in the integral equation.
I don't have a BT anywhere though. I have B prime of T.
B prime T.
Okay.
You know what?
Well, no, but I'm not trying to be picky. That's a different thing. I'm just clarifying. Go ahead.
So you would basically, when you go to separate that and get your answer for the 34 point whatever, you would take that B prime of T, separate it in with the equation.
You're saying do this?
Yeah, and then you replace the B prime of the equation with the numbers in the T spots in the equation.
No.
No.
In theory, sure. But I don't have B10 and B0.
No, but I'm saying you have the equation.
But I don't have the equation for B. So I can't plug 10 into the equation for B because I don't have the equation for B.
Where are you getting?
I'm integrating. I'm plugging that into the calculator and having it integrate between 0 and 10 for me. Is that right?
Yeah.
I just know the B prime equation. I don't know the B equation. So, whatever equation's here, you're not plugging into that, you're plugging into the level above that. I don't know that. So I can't use that approach. But I do have a calculator, so I just type it in there. Now we're just staring at each other.
I was staring at the board.
Oh, okay.
The other board that you just moved in front of.
Oh, I thought you were saying that board.
No, that one.
Look at this.
It's not going well. So you're going to type in your calculator 100 plus integral negative 13.84 e to the negative 0.173 t, comma 0, comma 10.
It's not really
With parentheses.
happening because I wasn't sure when you plugged in that equation how to be. Confused me.
I confused you how?
By just writing B prime T instead of the whole equation.
Look, you were fine writing the kind of T, it's just I got confused about when you played the equation because I like that. Whatever, I got it now.
Do you have it now?
This has it now.
Is it important? Is it important that I know what you were thinking?
No.
Should we just move on?
Yes.
All right. Any other questions? All right, go to 2013. So turn back to page 2013. The year itself was here.
Yeah.
When I hear go turn to problem 2013, I think there's just a lot that's in it.
Like 2013 had like a lot of good things,
G part A. Part A is basically a calculator thing. I want to know if you remember. I want to see if you remember how to do it.
But do we still have to write down like what we've done?
All you're gonna write is G prime of 5 equals, and then you're gonna put units, describe it, that stuff. So this is set, like basically, can you take the derivative at a point in your calculator? That's what I'm trying to check right now. So graph it, and then go, I think it's F5, with all like the math commands, find the dy dx. Yeah.
Doesn't it give the slope threshold thing in the problem? It says its process is around constant rate of 100 tons per hour. Or does that mean it gets rid of it?
So what's going on here is you got unprocessed gravel coming in at that G rate and processed gravel going out at a constant rate. So you have this giant pile coming, some's coming in, some's going out, but that overall amount just keeps changing.
Oh shoot! I feel the fifth.
The fifth? Oh, instead of at 5?
Yeah.
You're trying to type it in without graphing it, aren't you?
Oh, do you get a graph it?
So when you type the comma 5 like that in the type it in, it's going to find the fifth derivative.
What do you do then?
Graph it,
Oh,
as I mentioned like
yeah.
4 seconds ago.
Mine's not working like it keeps saying like undefined variable.
You can't put G in it.
Yeah, but X.
Ooh, that's why it's
it's decreasing at a negative rate, you're actually increasing.
Yeah.
Are we getting that in the calculator okay?
Can you explain like the explanation?
What did you?
Like I know the decreasing part, like the
Okay. So, like the general idea behind this problem is you've got 500 tons of gravel sitting there of unprocessed gravel. You've also got a rate. This is an amount, not a rate. That's an actual amount. G prime of T. Okay, so G of T is the rate being added, and then there's also some being taken out. So we also take gravel out at 100 tons per hour. So, and this is a really common setup for them. They'll give you, okay, there's an amount of something, sand, gravel, water in a pool, whatever. We're pouring water, sand, gravel in at a certain rate. We're also removing water, sand, gravel, whatever, at a certain rate. And those rates are not the same. Else this would just be the same all the time. Right? And then they're going to say, they're going to ask you questions like, well, how much is coming in this time? How much is going out this time? How much is there at this time? Like taking both ends into consideration. So that's what's happening here. You got 500 tons of gravel. We are adding to that pile at this rate, and we are taking away from that at this rate. And so we're going to
So we
ask
found
questions about that.
the G of
So G prime of 5 is how quickly the unprocessed gravel is coming in at that time. Because it's negative, it's decreasing. But before that, were there calculator issues? Should I come around and like show you some things? Calculator okay?
I was like integrating it since you're stupid.
Yeah.
So gravel is arriving, it's coming in and like making an increase, but it's decreasing because it like wasn't as much as it was before, or like
The rate that it's coming in is slowing down.
okay.
It's not
But
as
like
coming
it's
in
still
as-
adding to the pile, but it's like decreasing in the amount that it adds.
Okay, part B, find the total amount that arrives during the operation, during the hours of operation. So for those 8 hours, if I want to know how much arrived, what function describes to me the rate at which it's arriving? G of T. So how do I go from rate to amount? Take the integral. So part B, I'm going to integrate G of T. Because G of T is a rate. Just because it doesn't have a derivative, like a prime symbol next to it, doesn't mean it's not a rate. And I want to integrate that over the course of the 8 hours of the day. And then I just type that in my calculator. Yeah.
So G of T is a rate. Why is G prime of T a rate?
G prime is the acceleration. It's like the rate of the rate. So this is the change in the rate. That's what Maddie was saying. Like there's still gravel being added, but it's getting added at a slower rate. So it used to be like dumping onto this pile, and now it's just like trickling onto this pile. Sorry to talk about dumps and piles. Yeah.
Be like tons per hour squared then or no?
Oh yeah, this would be tons per hour squared. I have my label wrong on the first part. They didn't ask for a label, but I should have it correct.
Is it because it's the prime?
Yeah, because G is a rate itself, so G is in tons per hour. So the derivative of tons per hour is tons per hour squared. Part B, do we understand why we're doing this? Why we're integrating?
I'm not there yet.
Okay.
So you gotta figure out how much is going in.
Yeah, so what's the integral of a rate? An amount. So if you type that in, you should get 825 points. 551. G of T has what label? Tons per hour. So when I integrate that, what's the label? Tons. Kyle.
Never mind. I just read my calculator.
Okay. Part C and D are tougher, so let's clear up A and B. Are we good on A and B?
I have a question. It is the amount that arrived, but there's still 100 coming out every hour, so technically isn't that like 25 is what was added?
Overall, that's not what they asked.
I know.
Okay, but yes. Yes. Okay. Part C is the amount of unprocessed gravel increasing or decreasing at time T equals 5. Well, now we got to take into account we got this rate coming in, and we've got a rate going out. So I'm gonna write it out and then explain it, which is not ideal, I know, but I think it'll make sense when I do that. I'm gonna do G of here. Let's do this. I want to know, is the rate in minus the rate out positive or negative? That's what I'm trying to find out. You don't really have to write that on your test. I'm just like trying to explain what I'm doing. Well, what's the rate at which the unprocessed gravel is coming in? G of T. What's the rate at which the unprocessed gravel is leaving or getting processed? 100.
Wait.
So it says up in the question, the plant processes gravel at a constant rate of 100 per hour. So that's a rate. That's a derivative. Tons per hour. It's a rate. It's a derivative. G of T is the rate the gravel is coming onto the pile. 100 is the rate at which it's getting processed and therefore being removed. So if this is positive, is the amount of unprocessed gravel increasing or decreasing? Increasing. And if this comes out negative, we're decreasing. So find G of 5. Again, you have your calculator. This is exactly why you have your calculator. So let's find G of 5.
Good afternoon, everyone. I've got a few announcements for you today. The dual enrollment meeting has been moved to Wednesday, May 2nd at 10:35 a.m. If you would like to register, please contact Ms. Kaiser or fill out the Google form in your email. Freshman baseball practice for today has been canceled. There's a diversity meeting Wednesday, April 25th at 2:30. Have a great afternoon.
So now, if I do G of 5, it's 98.141. And again, you're just doing that in your calculator, which is important to know. So if you're not understanding how to find that, let me know.
Wouldn't it be 100 per hour though? Or is it just 100?
Because we're dealing in rates. So this G of T is in tons per hour also.
Oh, okay.
There's this many tons per hour coming in, this many tons per hour going out. So the overall tons per hour at that time is negative 1 point whatever. So they're both rates.
So is there trouble?
Well, the most decreasing. It's good, right?
Won't they not have a number to ship out after a while?
Oh, from that end, okay. I was trying to like decrease the pile.
Oh.
You were trying to send out more stuff.
Yeah.
Part D is going to take much longer than 2 minutes to explain, so
Okay.
That's fair.
we'll keep it rolling tomorrow. Oh, you don't have to do anything today.
You want to explain the 7th thing or do you want to just like